In the previous example, we had used the frequency response, and as such we only could get the steady state, which is the green dots over here. The green dots represents the steady state response. So you see that actually in this particular example the input was 1 and the output was 2. And for every example we have calculated, the output was simply 2 times the input. How to get the red dots in the past is that we had shown you to do the difference equation directly. But you also mentioned that we could have gotten these red dots through the Z transform. Let's see how in this one slide. So the blue is the input, the red is the difference equation generated, and we see that after n equals to 5, then the red dots becomes very similar to the green dots, becomes a steady state response. Right, now let's use a Z transform to do it. So simply we take the equation of the difference equation and we perform the Z transform, and we will get y of z with respect to x of z, and we will get h of z in this form, either as negative powers of z or positive powers of z, doesn't matter. Now to get yn for x of n equals to unit step, what we then do is that we would take the Z transform of x of n, and x of z is equals to z over z minus 1. This is the Z transform of the unit step. Y of z is simply the input, which is z over z minus 1 times the transfer function h of z. So this is h of z, this is x of z. Now what we then get is that we have z squared on top, z minus 1 times z minus 0.5. But remember, the trick is that to get the inverse Z transform properly, we have to solve y over z divided by z first. So we take one of the z and move it down here. So we solve the partial fraction expansion using just one single z divided by z squared minus 1.5z plus 0.5. This is nothing but multiplying z minus 1 times z minus 0.5. Now, I use RPK. Of course, you have to solve the partial fraction by hand. RPK shows us these results. Now, let's interpret the RPK first. Why is the numerator 1, 0? Is because the current equation that we have for the numerator is z. So z is represented as 1 to the power of z and 0 to the power of z. 1z plus 0. So the vector representing the numerator is 1, 0, not only 1. Okay. Now for the denominator, is the vector representing the denominator is 1, minus 1.5 and 0.5, which is this guy. RPK shows us that R is this 2 minus 1 and P is 1 and 0.5. So what we then do is that we take this and plug it here, take this and plug it here. So the R is the numerator, the P is the denominator in this expression. So the second one is minus 1 here and 0.5 here. So again, remember that we have did the partial fraction in y over z divided by z. Now we have a chance to move it up to the other side, the z. So once we get this expression, then there is a lookup table for it. 2 over z divided by z minus 1 is simply 2 unit n. So this is the steady state response. As n goes to infinity, is 2 times unit step. Why is this a transient response? Look, this is minus 1, so this is minus. Then what was 0.5 over at the partial of this z transform? Z over z minus 0.5 is simply 0.5n un. So this minus comes out, this 0.5n times un remains. So you realize that after n goes to about 5 or 10 steps, this 0.5 to the power of 10 becomes very small, and yn just simply becomes the steady state response. So this is a steady state response, this is a transient response, and you see that we have used this example to figure out how to use the Z transform to get the equation for the steady state and transient. But if we are only interested in the steady state, then we could have used the frequency response approach directly. That's all. Thank you.